Okay, we're going to start with number one. The question is, which shows 833,000 written in scientific notation? So we remember with scientific notation, the purpose of scientific notation is to take big numbers and turn them really small by multiplying them times 10 to the nth power, whatever power we choose, depending on how small you make it. So as you can see over here on your answers, we have all of them are 8.3. So that pretty much gives it away that our answer is going to be 8.3 times 10, but we're just trying to figure out to what power we're going to make it. Now, if you remember in scientific notation, the point is to make the number as small as it can get with still using a single digit whole number. So you'll always see a single digit as the whole number for scientific notation. So here we have 8.3. Now, how did we get 8.3? Well, we have 833,000. And we have a decimal point at the end. So in order to get it to 8.3, we got to move this decimal. So let's count how many times we move it. We move it once, twice, 3 times, 4 times, and then 5 times to make it 8.33. We don't need the zeros at the end, times 10. And since we moved it 5 times, it's to the 5th power. So our answer for this one is going to be C. Let's move on to problem number 2. The length of a room is 5.048 times 10 squared centimeters. Which number is equivalent to this length? Well, this again is a scientific notation problem. We're pretty much just doing the opposite. So we have 5.048. We're going to move it to the right this time instead of moving it back. And the power right here tells us that we're moving it twice. So it's going to move once, twice. So it gives us 504.8 centimeters. So for this one, the correct answer is C. Moving on to number 3. Number 3, we have 2/3 to the 4th power. Now, a lot of people will try to do 2 times 4 and then 3 times 4. That's not really what the power is all about. Remember that to the 4th power means you're multiplying whatever the base is to itself, however many times the power is, the exponent is. So this is going to end up looking like 2/3 times 2/3 times 2/3, and one more time 2/3 because there are 4 of them. So 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 should be 81. This is my answer. Let's see if it could be reduced. I know 9 goes into 3 and 9 go into 81. I know 3 and 9 do not go into 16. It doesn't look like it is reduced anywhere here. B is my answer. Number 4, Roberto paid $43.08 for 3 CDs. That's a lot for CDs, it seems like. All 3 CDs were the same price. How much did each CD cost? So if all the CDs were the same price, obviously they have to be divided up into the same price. So what we got to do is we got to take 43.08, which is our dollar amount for the total, and divide it by 3. 3 goes into 4 once. 3, let's subtract it as 1. Bring down the 3. 3 goes into 13 4 times. That's 12. Remainder of 1. Bring down the 0. Don't forget the decimal point here. 3 goes into 10 3 times. That's 9. Remainder 1. Let's bring down the 8. 3 goes into 18 6 times. And minus 18 will give us 0. We're done. Our answer is $14.36 each for a CD. I've never seen a CD cost 36 cents and change. They're usually $12.99 or something like that. This is expensive CDs. Must be new releases. All right, number 5. Dacia made a snack mix using the ingredients listed below. She used 1 1/4 cup granola, 3/4 cup peanut butters, 1/2 cup raisins, and 1/4 cup chocolate chips. What is the total amount of all 4 ingredients? And we have our choices down here. So looks like since it's asking for the total of all the ingredients, it looks like we got to add them up. So let's go ahead and start writing those down. We got 1 1/4 plus 3/4 cup peanut butter or peanuts plus 1/2 cup raisins plus 1/4 cup chocolate chips. As you know, when we're adding fractions, all the denominators got to be the same. They got to be common denominators. Now, they all do a pretty good job almost of all being the same, except this 2 right here. So what we're going to do is we're going to change that 2 into a 4, since all the other ones are 4, and we can easily turn a 2 into a 4 by multiplying it by 2. That's going to give me a 4. Remember what I do to the bottom, I got to do to the top, and vice versa. So 1 times 2 as well is 2. Also, what you might notice in this problem too is we have a mixed number here. I don't really want to add that mixed number. What I can do, I have 2 choices here. I can take away this 1, bring it out here, and then add all this up, and then bring the 1 in later. Or what I can do is turn this into an improper fraction. I'm going to turn it into an improper fraction because I don't want to forget the 1. So we know that we're going to go around the world for this one. 4 times 1 is 4, and 4 plus 1 is 5. So we're going to have 5 over 4 plus 3 over 4 plus 2 over 4 plus 1 over 4. All right, so we have all our common denominators. When we're adding, we don't add them. It's just our common denominator answer. But we do add our numerator. So 5 plus 3 is 8, plus 2 is 10, plus 1 is 11. All right, so our answer is 11 over 4. Hey, I don't see it over here. These are all mixed numbers, so it looks like we're going to have to turn this one back into a mixed number. 4 goes into 11 a total of 2 times, with a remainder of 3, and the denominator stays the same. So my answer is 2 3/4, or D. Moving on to number 6. Number 6, 3 1/4 times 3. So here we have a classic example of multiplying 2 things that don't really need to be multiplied and can't really be multiplied. So we're going to have to change one of them. We have 2 choices. We could change 3 into a fraction, or we could change 3/4 into a number or a decimal. It doesn't really matter which one we do. I always like turning them into fractions. I like fractions because to me, they're pretty easy, and I know a lot of you are scared of fractions, but hopefully I've taught you well and you won't be so afraid of them. So let's turn this into a fraction. So it's 3/4 times 3. So remember, we can turn any whole number into a fraction by putting it over 1. And the reason is because 1 goes into 3 times and it's still equal to 3. So when we're multiplying fractions, let's not forget that you just multiply the top, multiply the bottom. Fairly simple. So 3 times 3 for our numerators is 9, and 4 times 1 is 4. As you can see, it is written in fraction form, so I don't have to turn this into a mixed number. My answer is 9 over 4. It cannot be reduced, so my answer is D. Number 7. A recipe of 1 batch of cookies requires 2/3 of a cup of cooking oil. How much cups of cooking oil would be required for 4 batches of cookies? Okay, now I see why you guys start to get hungry during STAR testing, because these questions are delicious. So let's see. So we have 1 batch of cookies requires 2/3 of oil. If we're going to make 4 times as much batches, how much oil do we need? There is a lot of different ways to do this one. My favorite way, and hopefully you remember when I taught you this, is by using cross product. Cross product is the best way to compare numbers. So let's go ahead and do that here. So first I have one batch, and for 1 batch I'm going to put it over how much oil I needed, which was 2/3. I could turn this into a decimal if I wanted to, but I'm going to leave it like that. And that should be equal or proportionate to 4 batches, and since I don't know how much this is, I'm going to make it X. So now I'm going to go ahead and cross multiply what I have by using cross product. I can't multiply 1 times X because I don't know what that is. So I'm going to multiply 2/3 and 4. Remember, when we're multiplying a number and a fraction, we got to turn the number into a fraction. So 4 into a fraction is 4 over 1. That's going to give me 8 over 3. Then I'm going to take this number and divide it by the only other number I have left, which is 1. 8/3 divided by 1 is 8/3. So this appears to be my answer. However, I don't see it over here on the answers. So it must be turned into a mixed number. So let's see if we can turn it into a mixed number. 3 goes into 8, not almost 3 times, but twice, with a remainder of 2. and of course the denominator stays the same. So my answer is 2 and 2/3, or C. Number 8, which of the following is equivalent to 5/2? So, as you can see, we have numbers with decimals on them over here. So all we have to do is really divide this because it's putting it in whole number form. So if I just divide this, remember any fraction is a division problem. Just put in a division box. Remember the one that got there first, or the top or the left, goes inside the box. So it's out of the range. 2 goes over here. 2 goes into 5 2 times. That's 4 with a remainder of 1. I have to keep it going. Add a decimal point. That means I could add 0. 2 goes into 10 5 times. And I am done with this problem. My answer is 2.5 or B. Number 9. Tasha is buying a CD that is regularly $12.99 and is on sale for 1/4 off. Which expression can she use to estimate the discount on the CD? So here it's not really asking us what the total price of the CD is going to be after the discount. It's just simply asking us what expression is going to estimate the discount of the CD. So $12.99, as you can see right here, is estimated to be 13 for all 4 of these answers. So can't really go wrong when it comes to that one. But as you can see, all these are decimals for all the answers as well. So we just got to find what decimal matches up with 1/4. Now there are lots of ways to do this. Hopefully you know that 1/4 is a pretty common fraction, so you should know the decimal of it. But just in case you don't, remember every fraction is a division problem. So 1/4 is the same as writing in division box 1 divided by 4. So 4 goes into 1 0 times, of course. Add a decimal point, and then that gives me room to add a 0. 4 goes into 10 2 times. That's 8. With a remainder of 2, drop another 0 so we can keep this problem going. And 4 goes into 25 times. Now, a lot of you probably already knew that 1/4 is 0.25, so you won't have to do this, but it's helpful to know just in case you ever have to do it if you don't remember what fraction is as a decimal. So it looks here like our answer is C. All right, number 10, which is an irrational number? So remember, let's talk about what a rational number is first. A rational number is any number that can be written in A/B form. So it can be written as a fraction. So let's start from the bottom here. This is already a fraction. So even though it's negative, it's still a fraction. So that is a rational number. So I know that's not my answer. Here we have -1. -1 can be written as a fraction as -1/1. So that's not my answer. Now we have 2 square roots. So you might have a tough time deciding here which you can eliminate. But it shouldn't be that big of a deal if you try to figure out the square root of it. So the square root of 9 is 3. You should know that because 3 times 3 is 9. So can I write 3 as a fraction? Of course I can. I can write it over 1. So it doesn't look like it's going to be 9 either, but let's hold off on crossing it out until we look at the 5. The square root of 5, now the square root of 5, unlike 9, is not a perfect square. So the square root of 5 is going to be 2 point something long, some long number. So since it's a long number, let's just assume it's going to be 2.25629. Now this isn't what the square root of 5 is, but let's just assume I know it's going to be a long number after that. It's going to be a never-ending decimal. How can I put this number, if it keeps going out this way, how can I put this number over 1 if I don't even know where it ends? And that's pretty much the point I'm trying to make here. That's why 5, the square root of 5, is our irrational number. Because it keeps going forever, so I really can't put it into a fraction form, because if I don't know what a is, which is my numerator, how am I going to put it over 1? So square root of 5 is the correct answer for this one. Number 11. Which of the following is an irrational number? Here are those irrational numbers again. Remember, all these answers right here are square roots, so we're pretty much looking for the one that is not a perfect square. That'll probably give us our answer. So let's start with A. The square root of 144, so what times what equals 144, and we know that is 12. 12 can be written as a fraction as 12 over 1, so it's not going to be A. Square root of 16 is 4 because 4 times 4 makes 16. Any whole number can also be written as a fraction, so that's not it. Square root of 4 is 2. 2 times 2 is 4. You can put 2 over 1. Square root of 3. Once again, square root of 3 is going to be a never-ending decimal. So since it never ends, we can't really put it over 1 since we don't know where it ends. So your correct answer here is going to be D. Number 12. Which fraction is the same as 3.08? Alright, so remember how I told you every fraction was a division problem? Well, here we're going to have to figure out which one when divided equals 3.08. So I don't have to divide all of them. Actually, I can kind of go through them really quick to find out which one would not go into it 3 times, or maybe goes into it more. Maybe some of them don't go into it at least 3 times because this has the whole number as 3. So it definitely has to go into it at least 3 times. Or not at least, it definitely has to go into it 3 times and then have some kind of remainder. So let's find out what it is. 25. 25 goes into 56 twice. So the whole number here is going to be 2. Automatically I can stop here because the whole number here is 3. I know it's not going to be this one because it can't be. So 25 goes into 77 3 times. So the whole number is 3 here. I'm not going to go any further. Maybe that's the only one that's 3. So I'm just going to wait off and see if I get lucky on this one. 5 goes into 19 on C 3 times as well. So I'm going to wait to see if that one works out. 5 goes into 30. 5 goes into 36 times. So the whole number here is 6. That's a lot. That's definitely not equal to 3. All right. So now I'm going to go ahead and divide these to see which one I get 3.08. So I'm going to start with C, which is 19 divided by 5. 5 goes into 19 3 times, as we've stated before. That's going to give us a remainder of 4. Add a decimal. Add a 0. Bring it down. 5 goes into 40 8 times. It's 40, and we're done with this one. So it looks like the answer is 3.8. Hey, it's pretty close. It's not 3.8. It's asking which is the same as 3.08. So it's not this one, unless we did something wrong. But I don't think we did. Let's go ahead and do B, which is 75 divided by 25. So 25 goes into 77 3 times. That's 75. Minus that is 2. Let's add a decimal point, bring down a 0. 25 goes into 20. Well, that's not enough. So it goes into 0 times. Let's bring down another 0. 25 goes into 200 8 times. All right, so now we see why we decided to work it out. We figured out that B, 77 over 25, is equivalent to 3.08. All right, 13. A sweater originally cost $37.50. Last week, Moesha bought it at 20% off. How much was deducted from the original price? All right, these problems are tricky, and here's why. You have to understand what the problem's asking you. In this case, I always like to circle it or highlight it or do something. It's asking how much was deducted from the original price. Notice what it's asking you, or the different things it can ask you. It's not asking you how much the sweatshirt cost. It's asking you how much was deducted. Now, it's tricky because when we find the answer, I'm going to show you a little trick that they use to to trick you and make sure that you have different options, and if you do it wrong, you might still get an answer that's on here. So let's go ahead and figure this out first. So $37.50 is what it costs. So $37.50, and it's 20% off. So I'm going to go and multiply it by 20%. But as you know, I cannot multiply a number by a percentage because it just can't be done. So I'm going to turn this percentage into a decimal. And how I do that is I replace the percent sign with a decimal sign, a decimal point if it doesn't already have one, and move it twice over to the left, which is going to give me 0.20 or just 0.2 because I don't need the 0 at the end. So I'm going to go ahead and multiply those. 2 goes into 0 times. 2 goes into, or 2 times 5 is 10. Carry the 1. That's 5. Carry the 1 again, and that is 7,500. Whoa, that's a lot, but it's not really that much because I need to count how many decimal places I held, and I hold 3. So how much was deducted? It looks like it was $7.50 was the price of the discount. Now, $7.50 is the price of the discount, and $37.50 was the original price. So if you subtract them, you end up paying, for the sweatshirt, you end up paying $30. Notice how $30 is right here. Now, that is not the answer. That's how much a sweatshirt cost. But look at the question, what it's asking us. How much was deducted from the original price? It's not asking us how much it cost. And this is why these problems are really tricky, is because they will ask you different things. You will see another problem on here that we're going to go over that is the same type of problem, but this time it does ask us what was the final price. In this case, it doesn't. It's asking us how much was taken away by 20%, and we know that $7.50 was the amount that was taken away. The correct answer here is not D, but it is A. All right, 14. Jason bought a jacket on sale, 50% off the original price, and another 25% off the discounted price. If the jacket originally cost $88, what is the final sale price that Jason paid for the jacket? All right, here we go. The most important thing I can give you in advice for this problem is see how it takes off 50% and then takes off 25%. Do not add these up. The reason you don't want to add them up is because taking 50% off of this price right here, that's $88. And after that, we're going to get a new price for the jacket, and then we're going to take 25% off of that new price. If you add them up together, you're going to be taking 75% off the original price, which is not the same thing. I have a little story for this, and I hope you have time to listen to it. Let's say I have $20 in my pocket. And if I have $20 in my pocket and I give half of it to my friend Jason, then I now have $10 in my pocket. And if I give half of that to my other friend Chris, then I have $5 in my pocket. Now, if you were to add up the 50, half and half that I gave to two of my friends, half is 50% and the other half is 50%. So if I add them up first, it looks like I gave away 100% of my money, which means I would have none left. But what I actually do have is $5 left. So now you can see why you don't add the percents up before you do it. So let's go ahead and get started on this one. We have $88 and we're taking away 50%. Now, obviously we know 50% is half, and half of 88 is 44. So we're gonna take away half, and that's gonna give us $44. And if you don't know that half of 88 is 44, then you can simply multiply it by 0.5, like we're going to do right here with 25%. So half of it off is $44. Now, from that price, we're going to take another 25% off. So we're going to go ahead and multiply 44 by 25%. We have to turn it into a decimal. So we're going to move the decimal point over 2 places to the left. It's going to give us 0.25. And we're going to multiply these. 5 times 4 is 20. Carry the 2. That's going to give me 22. And 2 times 4 is 8. And another 8 here. Add them up. 0, 0. Carry the 1 here. And that gives me 11. 2 decimal places I'm holding. So it's going to be $11. Now, $11 is what got taken off of the 25%. It's asking for the final sale price of the jacket. So remember, it was $44 after we took it away from 50% off from 88, and now we took another $11 off, so I'm going to minus $11, and that is going to give me the total of the jacket, which is going to be $33. Very nice. My answer is B. Number 15. Marl borrowed $200 at 12% simple interest for 1 year. If he makes no payments that year, how much interest will he owe at the end of the year? So another 1% turning into a decimal. So I'm going to have my price of the loan, which is $200. And since it's simple interest, that means he just pays 12% a year. And he didn't make any payments, so he didn't pay it down anywhere. So we're just going to simply multiply this by 12% or 0.12 since we're turning into a decimal. That's going to be 0.004. Got to put my placeholder here and 0.002. So it looks like he is going to pay $2,400. Wow, that's a lot. Okay, as you can see, I'm missing my decimal point. So let's find out how many decimal places we held. We hold 2 decimals. So my decimal point is going to go right here. My actual amount that I have to pay in interest is $24, and the correct answer is D. All right, here we go. Tamika works in a shoe store and is paid a 12% commission on her sales. In January, her sales totaled $3,740. To the nearest dollar, how much did Tamika earn in commission for her sales in January? So for her sales in January, she sold $3,740 worth of merchandise. She gets 12% commission, so of course I'm going to multiply that by 12%, which is 0.12. You should know that by now. And then let's go and multiply this. That's 0, 8, 14, carry the 1, that's 7. We got 0, 4, 7, 3. 0, 8, 8, 14, carry the 1, that's 4. How many decimal places we have here? We have 1, 2. So 1, 2. Looks like she made $448.8 in commission. But hey, I don't really have that number here. I have 449, but just because the number is close, I shouldn't really put that. 20 cents is a big difference. I don't understand why this isn't here. Let me go back and read the problem. Tamika works in a shoe store and is paid a 12% commission on her sales. In January, her sales totaled $3,740, which I did do correctly, to the nearest dollar. Oh, that's what I forgot to do. How many times does that happen to you? So to the nearest dollar. So that means that I can round this up to the nearest dollar. Since 80 cents is almost $1, I'm going to make this $449. And that means my answer is B.